This one is a very simple question from arithmetic progression. The only pain point in this question, what makes it a little difficult, is that the calculation becomes a little tricky. Let's get started. It was a 3-mark question that appeared in 2017 CBSE board examination class 10. How many terms of an AP? 9, 17, 25. The first 3 terms have been given. Must be taken to give a sum of 636. Let's jot down the points quickly. The AP given to us, the first 3 terms are 9, 17, 25. So the first term of the AP is 9. The common difference is equal to 8. So A1 equals 9. D, the common difference, is equal to 8. Sum of the first n terms is equal to 636. The only concept involved is knowing the formula to compute the sum of the first n terms of an AP. What is that? It's n by 2 into 2a1 plus n minus 1 into d. We're going to plug in all data that we have and then find out whatever is left, and we'll find that value. So this is the formula that we have. Sum up to n terms, which is 636, is equal to n by 2 into 2a1, 2 into 9, plus n minus 1 into the common difference, which is equal to 8. So one equation, one variable case. So n is the only variable that we need to find out. So 636, this basically becomes, is equal to n by 2 into an 18 plus 8n minus 8. So this is 636 is equal to n by 2 into 18 minus 8 is a 10 plus 8n. We can cancel the 2 with both these terms to leave us with a 5 and a 4n. So this equation basically becomes 4n square plus 5n equals 636. Let's take the 636 to the left hand side. Minus 636 equals 0. The problem in this question starts from this moment. Till this, it was very straightforward. Factorizing this quadratic equation is the pain point. Let's set about doing that. The product of 4 and 636, how all do we break it? Whenever you encounter something like this, when this number is not a friendly one, prime factorize it quickly to get some idea. Prime factorizing this will leave us with 4 into a 53 into this portion. We can even leave it. Let's not even prime factorize it. 53 is one of the crucial prime factors. So 53 has to be a part of one of the 2 parts that we are dividing it. So 53 happens to be one part. It's a good hint for us. The other part, if it is a 4 into 12, which is a 48, the difference works out to be a 5. So how does this factorize? This basically factorizes as 4n square plus 53n minus 48n. 53 into 48 is nothing but 4 into 636 minus 636 is equal to 0. And take n common from the first 2 terms. N into 4n plus 53. Take a 12 common from the third and the fourth term. Minus 12 into 4n plus 53 equals 0. From this moment, the factorization becomes easy. Once you know how to break it, then it's very simple. So 4n plus 53 into n minus 12 is equal to 0. Translating to the fact that n is equal to minus 53 by 4, or n is equal to 12. N is the number of terms. Number of terms can neither be a fraction nor can it be negative. So the value of n is equal to 12. So if you take up to 12 terms of the sequence, you will get a sum which is equal to 636. Quickly run through this calculation in a printed form. We have 636 is equal to n by 2 into 2a1 plus n minus 1 into d. Cross multiplied this 2 to arrive at a formula that looks like an equation that looks like this. Divide this entire equation by a 2. So we'll get 4n square plus 5n minus 636. Quickly realize how to factorize it, which is 53n minus 48n, giving us an answer of n equals minus 53 by 4, or n equals 12. N can neither be negative nor be a fraction. So n is equal to 12 is the answer to the question. So this part is the only painful part in this entire question.